Hello my dear students. Now in this session we'll speak about the extraction of iron from its ores. So the extraction of iron from its ores will take three steps. First from the rock till the industrial uses. How we can use iron, how we can deal with the iron rock and then extract the iron from the rock and adding some elements to improve the physical and mechanical property of iron to be used in industrial uses. There are three stages or three phases which the iron undergo or go through to be extracted and produced in the industrial uses. The first stage is ore dressing. Dressing is preparing the ore to be used in a reduction process or to take place or to be placed in the blast furnace or the high furnace or the midrex furnace. So we cannot put in the furnace the rock as it is or the ore as it is. So we have first to prepare this ore to be placed in the reduction furnaces. Then after the reduction furnaces or the reduction of ore process, we place the iron into another furnaces, which is some of them like the oxygen converter will oxidize the traces, the remnant traces or the remnant impurities in the iron. So there are three phases. The first phase or the first stage is ore dressing, preparing the iron ore to be dealt with after time or afterward. Second is the reduction using midrex furnace or high furnace, then the production process of iron. So first we'll speak about ore dressing. Ore dressing including the improving the mechanical and physical properties and improving the chemical properties. Ore dressing means to prepare the iron ore to be after that reduced in the furnaces. So how can we dress this iron ore or prepare this iron ore? Through increasing the iron percentage in the ore. How can we make it? Through what is called mechanical and physical improvement and then chemical improvement. Mechanical and physical improvement, this means to crush the rock. We cannot put the rock in the midrex furnace or high furnace of those who make reduction for the iron ore just as they are in large pieces. So we have to grind the rock first or the ore first. Then we have to this crushing will produce very small minute particles. So we have to collect these particles to be able to be reduced to be convenient and suitable for the reduction process. So the first phases of the improving of physical and mechanical properties are opposite each other. The first is crushing, the second is sintering. Crushing make large pieces into very small pieces to be able to be reduced, to be convenient to be reduced in the furnaces. The second after crushing is sintering, which is collecting the very fine small particles, the very tiny particles, into larger particles to be able to be reduced or to be suitable for the reduction process afterward. Crushing and sintering. These are the two phases in the ore dressing in the mechanical and physical improvement. Afterward, we'll concentrate this ore. Concentrating this ore through three things. Either by electric separation, magnetic separation as it is iron and has magnetic property, or by surface tension. These are the improvement, the physical and mechanical improvement: crushing, sintering, and roasting. Afterward, this ore dressing will go into chemical improvement or to improve the chemical properties of the ore. Improving the chemical properties of the ore through roasting. Roasting to expel humidity, to oxidize some undesirable material, or to increase the percentage of iron, as in case of midrex, which is ferrous carbonate. So let's go through the ore dressing first. The ore dressing here to improve the physical and mechanical properties through crushing process. So we crush this rocks or this ore into small pieces. Afterward, sintering means collecting these small particles, and these very tiny particles which arises from the cleaning of the furnaces or from the grinding itself, crushing process. So to collect these very small particles into bigger particles to be able or convenient for the reduction process. Afterward, as we have spoken before, concentrating process aiming to increase the percentage of iron in the ore, and it is performed by surface tension, magnetic separation, or electric separation. So these are the improvement of physical and mechanical properties which are part of ore dressing. It consists of crushing process, sintering process, and concentrating process. Concentrating process through surface tension, magnetic separation, and electric separation. So afterward, we have to improve the chemical properties by roasting process. This roasting process to dry and expel humidity from the ore and to increase its percentage, the iron percentage. Like this, ferrous carbonate, which is siderite, its percentage is 48.5% of iron. After it is heated in air, it transformed into iron 2 oxide or ferrous oxide. Ferrous oxide is oxidized by oxygen of the air to ferric oxide. Ferric oxide, its percentage is 69.6%. So the percentage of iron through rusting here changes from 48.5% of iron into 69.6% of iron. So the percentage of iron in siderite increases by roasting. So there is another example for roasting. Limonite. Limonite is 2 molecules of ferric oxide with 3 molecules of water inside one compound. This water is called hydration, water of hydration. So we have to get rid of this water of hydration through rusting. Rusting of limonite, which contains about 40% of iron approximately, to be converted to ferric oxide, anhydrous ferric oxide, or ferric oxide without water of hydration. Its concentration or the ratio of iron in it equals 69.6% of iron. So by roasting of limonite, its percentage or the percentage of iron converts from 40% into nearly 70%, 69.6% of iron. Okay, so roasting also make oxidation of some impurities. What is the importance of this oxidation? Look, the rocks are solid, and we all know that the oxides of nonmetals is gases or are gases. Okay, so sulfur, it is solid as a nonmetal. So when it is oxidized into sulfur dioxide, it transformed from solid in the ore into gases in the air. So we get rid of some of impurities through rusting. Here phosphorus is oxidized into phosphorus pentoxide. Phosphorus here is solid. Phosphorus pentoxide is vapor. So we get rid of phosphorus and sulfur as they are nonmetals by oxidation. When they are oxidized, they are transformed from the solid state, elemental solid state of sulfur and phosphorus, into gaseous state in the form of oxides, sulfur dioxide gas and phosphorus pentoxide gas. Okay, we'll see afterward. We'll speak about the reduction process. What is the reduction process? The reduction process or dressing aims to increase the percentage of iron, get rid of humidity, get rid of other undesirable elements or substances inside the rock. Then there is still a high percentage of ferric oxide. So after roasting, after improving chemical, mechanical properties of the iron ore, the most percentage or the most ratio of the rock or the ore is ferric oxide. So ferric oxide must be treated to get rid of oxygen inside the molecule of ferric oxide. Get rid of oxygen means reduction. So we undergo reduction of the iron ore, which is mainly ferric oxide, by two ways. The first way is the blast furnace or the high furnace. The blast furnace or the high furnace, using carbon from coke, adding coke to the furnace, then this coke will react with oxygen, forming carbon dioxide. This carbon dioxide reacts with excess coke, then it forms carbon monoxide, which is a very strong reducing agent. Very strong reducing agent, blast furnace. How it uses, we use here carbon monoxide, which arises from this reaction. Coke and oxygen oxidized into carbon dioxide, then carbon dioxide is converted into carbon monoxide. Carbon monoxide is used to reduce iron from ferric oxide into iron. Here we have to notice that the temperature here, the temperature here is higher than 700 degrees Celsius. When we want to transfer iron from the oxide by reducing agent into iron, elemental iron, in this case we have to raise the temperature higher than 700 degrees Celsius, and it is a very important notice. You have to put it into consideration. So there is another way of reduction in Midrex furnace. Midrex furnace, here we use the natural gas, which is composed of more than 90% of methane. So we use methane gas here with carbon dioxide from air and water vapor. Okay, so we have to make this reaction, methane, carbon dioxide and water vapor, to form the water gas. Water gas composed of carbon monoxide and hydrogen. Water gas, by the way, is a mixture, because there is a question on that. Water gas is a mixture, it is not a compound. A mixture of a compound which is carbon monoxide and hydrogen, this is a water gas. Water gas is a mixture from a compound which is carbon monoxide and metal, and an element which is hydrogen. So here we use methane, carbon dioxide and water to form water gas, which is carbon monoxide and hydrogen. Each one of them is a very strong reducing agent. So we use the mixture of carbon monoxide and hydrogen to reduce ferric oxide into iron, elemental iron. Okay, this is in Midrex furnace. So here the temperature must be higher than 700, because we transfer the oxide into elemental iron. So the temperature in both of these reactions is more than 700 degrees Celsius. Okay, here what is, when you ask it, give reason or explain or mention the role of coke in the blast furnace. Now coke react in hot air with oxygen to be oxidized into carbon dioxide, then with excess carbon, with the excess coke, it reacts with carbon dioxide to form carbon monoxide, which is used in high furnace or the blast furnace to reduce hematite or ferric oxide. Okay, second thing here, water gas rule in the Midrex furnace differs from its rule in the Fischer-Tropsch method. Fischer-Tropsch method, if you remember it, in the economic importance of iron, it is used as a catalyst in Fischer-Tropsch method, which is the method to prepare the liquid fuel from the water gas. So water gas, which is carbon monoxide and hydrogen, by Tropsch-Fischer method and by using iron as a catalyst, is transferred into liquid fuel. But here in Midrex furnace, this water gas is not converted to liquid fuel. It is used as a reducing agent to reduce ferric oxide into iron, and the temperature here, remember, it is higher than 700 degrees Celsius. Okay, the iron production to improve the properties of iron and to have iron in the good industrial uses or convenient to the industrial uses and to the human uses in different fields. So we have to first remove the remaining impurities. There is a lot of impurities that will remain after the reduction if they are small, but they are not desirable in some cases to be suitable for the industrial uses. So we have to get rid of the remaining impurities of iron resulting from the reduction of furnaces or the reduction furnaces. Then adding some element, the addition of some other elements to make some alloys or to improve the properties of iron, its physical properties or chemical properties, and to improve its hardness, its ductility, and other properties that want to improve to use iron in the industrial purposes. So first we have to remove the remaining impurities that is resulted from the reduction furnaces. Then we have to add some elements to improve or to give the produced steel the required properties for the industrial uses. So we just here in our curriculum in the secondary 3 we want the names only. In the previous curriculums we study all these in details, but here steel industry is carried out by one of the 3 types of furnaces. Only the names. When you ask that what is the furnaces where the steel is produced, you have to know that it is oxygen converter or open hearth furnace or electric furnace. So electric furnace, open hearth furnace, or oxygen converters, they are furnaces used, or they are like matrix and blast furnace, but they are used to produce iron, to in the production of iron. Okay, oxygen converter, open hearth furnace, and electric furnace. Let's have some questions about the extraction of iron. If we remember with each other, iron first go through ore dressing. Ore dressing means improving chemical and mechanical and physical properties. Mechanical and physical properties through crushing, which grinding the larger particles of the ore into small particles. Then after this crushing and cleaning of furnaces, there appear a lot of very tiny particles which cannot be reduced. So we have to collect or to deal with these particles, to collect them in larger molecules or larger particles to be able to be reduced or to suitable to the reduction process in the high furnace or the blast furnace or matrix furnace. Okay, so after this, after crushing sintering, we have to memorize that there is a concentrating through electric separation, magnetic separation, and the surface tension. Okay, then afterward improving the chemical properties of the iron. Look at this. Here improving the physical and mechanical properties through crushing process, sintering process. Okay, crushing, grinding the ore, then collecting them in sintering process to be suitable to the reduction process, then concentrating through three ways, either surface tension or magnetic separation or electric separation or both of them all. Okay, then improving chemical properties through roasting to expel humidity and to increase the concentration of iron in the ore, then to get rid of some non-metal elements through evaporizing them in the form of oxides. Okay, then the reduction process happen in the blast furnace or matrix furnace. Blast furnace to use coke, which is oxidized by heat into carbon dioxide. Carbon dioxide reacts with excess coke to form carbon monoxide. Carbon monoxide is used to reduce iron with a temperature higher than 700 degrees Celsius to form or to produce iron in the elementary state. Or we can use natural gas which contains mainly methane, CH4 methane, with carbon dioxide and water to transform them into by the chemical reaction into carbon monoxide and hydrogen, which are the water gas, a mixture of carbon monoxide and hydrogen. They are used as a reducing agent here in Midrix furnace to reduce the hematite or the ferric oxide into elemental iron. Okay, so here production to get rid of the remaining impurities inside the iron and to add some elements to improve the character and properties of iron. Then steel industry is carried out by oxygen converter, open hearth furnace, or electric furnace. So let's have some question. Which of the following choices represents the correct sequence of the processes of preparing iron ores which are being used in the blast furnace? So here the last preparation before putting in the blast furnace or Midrix furnace, improving its chemical properties, through roasting. So sintering is not the last, but roasting is the last. So C is not correct. Roasting, then washing is a surface tension. It is a concentrating. Roasting is supposed to be after concentrating. So it is also wrong. So the last thing in the preparation or dressing is roasting. Roasting here is correct and roasting here is correct. But what is here? Sintering after surface tension. Surface tension is concentrating the iron ore. Okay, electric separation, magnetic separation, or surface tension, or both, all of them, all in this stage. But sintering after crushing. So crushing, sintering, surface tension. So it is not correct. You are with me? Okay, concentrate or remember with me what the explanation is, or you may listen to the explanation once again. Okay, it is starting with crushing, sintering, magnetic separation, which is concentrating, and washing also, and ends with roasting. So the correct answer here is B. Starts with crushing and ends with roasting. Let's have another question. The following substances are used in the extraction of iron from hematite except. Okay, we want the substance which is not used in the extraction of iron. Coke is used, as coke is oxidized to carbon dioxide, and carbon dioxide reduced to carbon monoxide. Then carbon monoxide used in the reduction of iron ore in the high furnace or blast furnace. Carbon monoxide also is used, carbon monoxide gas used alone in the blast furnace, or used with hydrogen as a water gas in the Midrix furnace. So it is used. Methane with water vapor and carbon dioxide converted into carbon monoxide and hydrogen, which is the water gas, to reduce the iron ore. So it is used also in the extraction of iron. Sulfur trioxide is not used. So this is the answer. Sulfur dioxide here is the answer, because he wants the exception, the substance which is not used in the extraction. We use coke, we use carbon monoxide, we use methane, but we do not use the sulfur trioxide gas. Let's have another example. Okay, what happens when the hematite is converted to steel? Yes, or dressing, then reduction, then oxidizing or oxidation by the oxygen converter or open hearth furnace or electric furnace. So reduction in the Midrix furnace or blast furnace. Okay, but it is not only here reduction then oxidation. Yes, reduction in the Midrix or high furnace, then oxidation in the open hearth furnace or oxygen converter or electric furnace. So this is the answer. Okay, the answer is reduction in the furnaces, in the Midrix furnace or blast furnace, then oxidation in the oxygen converter, electric furnace or open hearth furnace. This is the correct answer. Let's have another example. Okay, at this moment we finish this session. Thank you.